Welcome to your tour of the Paleozoic rocks of the Lincoln, Nebraska area. Today I'm going to be giving you a tour of Schramm State Park in Gretna, Nebraska, where there is a nice outcrop of Paleozoic rocks as well as some Cretaceous rocks. But we will be focusing on the Paleozoic rocks today. So just get a feel for what the landscape looks like here. Now, let's talk a little bit about the overall geologic history of Nebraska. We see all four major eras: the Precambrian, Paleozoic, Mesozoic, and Cenozoic. The Precambrian, we only have drill cores to give us evidence of any Precambrian rocks in Nebraska. There's no superficial exposure of Precambrian rocks in Nebraska, but from these drill cores, we only see metamorphic and igneous rocks, no fossils to be found. As we move into the Paleozoic, there's no surface exposure of any rocks from the Cambrian through to Devonian time, but there is evidence from drill cores of warm, shallow seas, as we will soon see, with few fossils in the samples, such as trilobites, corals, and brachiopods. During the Paleozoic, there was many changes going on in terms of climate, geography, flora and fauna. Sediment was being deposited when global sea level was high, and it was being eroded when the sea level was low. In the eastern side of the state, we see some subsidence from the Humboldt Fault, which allows for the accumulation of a thin drape of rock over the rest of the state. In the late Paleozoic, so essentially the Carboniferous, there's rivers which coming from the east, which are depositing sediments and creating swampy deltas as they move westward. By the end of the Permian, most of Nebraska was above sea level, and amphibians, fish, and aquatic plants thrived in fresh and brackish water. As we move into the Mesozoic era, we don't see any rocks from the Triassic or Jurassic era because erosion was outpacing deposition at this time. We do, however, have a Cretaceous era shallow seaway which spread north up into Nebraska. At this point, dinosaurs and flowering plants were abundant, as well as marine animals in the warm marine waters, such as giant sea turtles, plesiosaurs, fish, and ammonites. And then to finish it off, moving into the Cenozoic era, we have the Tertiary, at which time the western interior seaway had completely withdrawn. Sediments were being deposited by rivers and lakes. We see mammals, birds, and reptiles, volcanoes in the young Rockies, which would occasionally cover the entire surface with ash. And we have preserved Ice Age elephants, horses, and other vertebrates from the glacial deposits of the Pleistocene. So now let's look a little bit deeper into the Paleozoic. Paleozoic means ancient life. It lasted for about 291 million years, from 542 million years ago to 251 million years ago. The Paleozoic era can be split up into 6 periods, and those can be further split into 23 epochs, which we will look at in just a few minutes here. So starting off with our first period, the Cambrian. At this point, there's no rocks that are present on the surface from the Cambrian era. We do, however, from drill cores, we can see that most likely the Cambrian era rocks in Nebraska are very similar to those of, say, the reef fossils in Missouri. So there's most likely there were trilobites, brachiopods, stromatolites. 514 million years ago, Gondwana was the first supercontinent globally, and life was becoming more abundant. Climate was tropical to subtropical. And then as we get to 510 million years ago, the Precambrian basement was exposed at this time, and as it eroded, it created an unconformity which the Cambrian rock could be deposited on. And then at 500 million years ago, we're into the late Cambrian. We see shallow seas. There's a record of thin beach sand deposits, and on top of the sandstones, then carbonate rocks were being deposited until the early Ordovician time. And so the Cambrian and Ordovician rocks are thickest in the eastern side of the state, and then they become absent as you move west in the state due to erosion. So moving into the Ordovician, very similarly, there's no rocks that are actually presently exposed, but just like the Cambrian rocks, they're most likely were similar to the Ordovician rocks and fossils of Missouri. So we see most likely there was brachiopods, bryozoans, gastropods, trilobites, corals, and also similar to the Cambrian, the Ordovician rocks are present in the eastern side of the state but eroded from the western side of the state. As we move into the epoch of 485 million years ago, we see a shallow sea with carbonate rocks being deposited, specifically dolostone. In southeast Nebraska, we see uplifting and erosion, which created an erosional gap in the rock record. And then moving into 470 million years ago, the seas started to advance across the state, and we see carbonate rocks starting to leave behind thin beachy sands. This was the time when the St. Peter sandstone was being deposited, which was a very pure sandstone with uniform-sized quartz grains and very little cement. It was very porous and permeable, which was a good reservoir for the formation of oil and petroleum. 450 million years ago, the waters start to become deeper, sands are becoming buried by more carbonate rocks, and these carbonate rocks were also producing oil. And so now we'll move into the Silurian time frame. Just like the Cambrian Ordovician, no fossil record, very little exposed, none exposed on the surface. So we can assume that the fossil record would be very similar to nearby states, so most likely brachiopods, chain corals, snails, and other marine invertebrates. Looking specifically at 430 million years ago, we see another erosional gap, which created an unconformity. And on top of that unconformity, there was a deposition of more dolostone. And then at 420 million years ago, we see another erosional gap. This is right at the end of the Silurian, so this is an erosional gap between the Silurian and the Devonian. So looking at this little So looking at this diagram, we see that the Silurian was not widely present across the U.S. Well, not widely present in Nebraska, but also not across the U.S. due to later erosion. Now we'll move into the Devonian. At this point, the state of Nebraska was above sea level. Then it slowly rose to cover all of Nebraska with warm, shallow sea. We don't see really any fossils in the actual rock record, but we can assume that it was similar to surrounding states such as Missouri, so brachiopods, coral, bryozoans, trilobites. By the end of the Devonian, the sea had completely receded, and at this point erosion was outpacing deposition. Looking more specifically at 400 million years ago, we get an erosional gap in the rock record. At 385 million years ago, thin sandstone units are being deposited, and at 360 million years ago, the sea is rising, carbonates are being deposited in the shallower areas, and shales are being deposited in the deeper areas. At 356 million years ago, looking more globally, North America is starting to take shape. We have a tropical climate, and sandstone, shale, clay, and limestone are all being deposited, but little coal is being deposited at this point. So moving into the Carboniferous, the Mississippian epoch, we have plate collisions in the east, which are creating the Appalachian Mountains, which is creating gentle uplifts in the actual state of Nebraska. As land is rising, the sea is draining, and we're getting some more erosion. And then moving into the early Pennsylvanian, the seas are returning, Rivers carry sediment from the Appalachians westward, forming swampy areas along shorelines. We see marshes and swamps becoming coal beds, which contain fossils of ferns and giant horsetails. The water starts fluctuating more in depth, and so offshore we get this oxygen-deprived black shale, which has very nicely preserved shrimp fossils, conchids, bony fish, sharks, and other cartilaginous fish. And then in the shallow waters, we get limestone reefs with fossils such as stromatolites, fuselids, brachiopods, bryozoans, mollusks, corals, trilobites, eurypterids, and crinoids. And then by the end of the Carboniferous in western Nebraska, we see the sea level is western Nebraska is emerging above sea level again. The coastal plains start forming from sediment of the ancestral Rocky Mountains, which contain paleosols. Looking at 345 million years ago, once the seas started transgressing, then the carbonate layers started being deposited with more unusually high level of chert nodules. And then at 325 million years ago, we see the South American plate is colliding with the North American plate, which instigates the Ouachita orogeny, creating the Ouachita Mountains. And then over to the eastern side of the continent, we see the European and North American plate are colliding, creating the Appalachian Mountains. And then we get an erosional gap in the rock record at this point. Due to the Ouachita orogeny, Nebraska ended up losing a lot of rock due to the uplift and erosion that happened with that whole orogeny. And so moving on to the Permian. The Permian is exposed mainly in southeast Nebraska. Nebraska was above sea level for half of the Permian, and then the other half it was covered by warm, shallow sea, which was filled with marine life. Depth altered, and with it deposition of limestone reefs, sediments, and also black shale was being deposited in the deeper areas of the water. And so the limestone contained fossils such as stromatolites, fuselids, brachiopods, bryozoans, mollusks, corals, trilobites, eurypterids, and crinoids. And then in the black shale we find fossils of very well preserved crustaceans, chondonts, sharks, and fish. And then at this point the shoreline began basically moving back and forth, but as the sea line started to dry up more, we get a dry climate, which left the land as an arid desert-like land rather than having swamps and marshes. And as the sea retreated, erosion removed much of the Permian rock record. So looking at 315 million years ago, we see here on this map the Pennsylvanian seas are advancing over an eroded and faulted surface. Looking more globally at 306 million years ago, North America is nearly completely formed. And then 300 million years ago, we see cyclothen deposits occurring when the sea levels are high, and black shales being deposited at this point. And then at 290 million years ago, we have a transitioning sea level. Limestones are being deposited. Permian rocks are being deposited, such as shale, limestone, and sandstone. And then we also see evidence of gypsum and salt, which are various types of evaporites, which indicated that the climate was indeed dry and arid as the seas were drying up. And then we take a look at 275 million years ago. The sea levels are much lower. We see deposition of coal and paleosols, and we start gradually shifting toward a more terrestrial condition for the state. And then at 260 million years ago, terrestrial conditions are producing an erosional gap, resulting in an unconformity right at that break with the Permian and Triassic era. And looking globally at 255 million years ago, North America is mostly formed and is separating now from the European and South America plate, and the climate is starting to become more seasonal as North America starts to find its permanent place. So now I want to take a little look at some of the fossils that we'll find specifically at Schramm State Park. First of all, we'll see lots of fusulinids, and fusulinids are protozoans of the phylum Foraminifera. They are one-celled organisms that live at benthic levels of the sea, and they became extinct at the end of the Permian era, and these are characteristic. Their shells are very tiny and rice-shaped, and that's how you can easily identify fusulinids. The next thing that we'll see is rugose coral. This kind of coral can be colonial or solitary. Here we're seeing it as a solitary coral, and their skeleton is made of calcite. And fun fact for you, rugose coral is actually the state invertebrate fossil of Nebraska. Next we'll see bryozoans. Bryozoans are always colonial. They never live in individual organisms. There are various forms that they can take. They can look more twiggy or more spread out. In this case here, we're seeing a very fine lacy form. And actually, bryozoans, some forms of them did survive the Paleozoic era. And then next on the same picture here, we see a brachiopod, and that's a little shell-shaped fossil on the edge. And brachiopods are very similar to clams or mollusks. The difference is that brachiopods actually exhibit symmetry, whereas mollusks do not. And last but not least, there are tons of crinoids here in the rock record at Schramm State Park. Crinoids are echinoderms, also referred to as sea lilies, because when they were living creatures, they would have these long stems and kind of like fern-like leaves coming up off the top, and they would anchor themselves to the sea floor. Most went extinct at the end of the Permian era, though one subclass still exists today. Now, back to our outcrop tour. I have a map here to show you some reference points. The yellow arrow is Lincoln, where I go to school, and the red arrow shows Schramm State Park about 30 minutes away. The other purple blips show other recommended locations in the Lincoln area for seeing Paleozoic outcrops. Just as a brief overview, we're going to see a lot of alternating shale and limestone as the sea levels transgressed and regressed, and then we will observe an unconformity in which we jump from the Permian to Cretaceous. So we're going to start our tour by walking up the right side as you face the cliff. And then we'll make our way back over towards the middle, basically right in front of this outcrop of some shale, some limestone, and then as we zoom in here, we're going to focus in on the shale first. So this shale is the Eudora member. It's dark gray to black, indicating offshore deposition. We see some marine fossils in here, and it's very clayey, just like you would expect from shale. Here we can see some of the little marine animals that are fossilized in the shale. And then as we look above the shale, we're going to move up to some limestone. And this limestone, as we zoom in here, we see a lot of some marine fossils, but especially fusulinids. As we keep zooming in here, you can see a great example of all these little fusulinids, these little rice-shaped organisms, and these are abundant throughout the entire stratigraphic section here. And then as you look to your right, as we're facing the cliff, we look over and we can see how far this tablature of the stratigraphic layer extends. And we know that this is still the same layer, since it's a little difficult to tell based on the pictures. So here's a big screenshot. So we're standing kind of at the left side here in the middle, and then looking towards the right side. And then as we walk over to that right side, then we can look down and kind of see where we used to be standing straight across from us and looking down into the parking lot and such. And so here's another shot of the fusulinins on this far right side of the outcrop, showing us that this is still the same layer based on fossil succession. And then on the top of the layer, so the fusulinins are more like on the lateral face of the layer, and then if you're looking straight down on top of the layer, then we see some more of these marine fossils, which would make this more of like a pack stone if you're trying to categorize the actual grain size of the limestone. And we're just getting some more close-up shots here. And then, so now from where we're standing, looking straight across, this just gives you another view of what some of the layers are looking like going down the cliff. And then as we turn to our right from here, looking straight up, we have a 6'5" man for scale here. And we're looking up, so we can see kind of right in the middle, as we have it circled. So this is another limestone, little outcropping there. And so what we're seeing is we have some paleosols up top that has basically covered this section of the outcrop, and that's where that red soil is coming from. So as we look up closer, this limestone outcropping we see here, so this is a nice shot of some displaced limestone from this same section, and then this is what it looks like up close in place. And then moving across, we start seeing that the limestone is alternating with some shale, and this is indicating to us that as we go from more limestone to less limestone, we're going from a shallower depth to a deeper depth. So this would suggest that sea level is rising as we go from more limestone to less limestone, and the more shale we get, the deeper offshore we are. And so we start seeing those thin layers of shale popping up. So now we've passed that stratigraphic layer. We're going to start moving our way up the cliff even more. And so now as we move up, we start seeing some more of this red iron-rich soil. And this is a paleosol. That's some of it's fallen down. So looking up, this is a nice panoramic. We can see the nice color change. So we have some of the more iron-rich paleosol, which is the red on the bottom, and then the less iron-rich is the yellow paleosol on top of that. And then we have this nice tablature of limestone on top of that. And so moving up closer here, just another long view shot. And then so we'll take that in, and you can just see how like kind of clayey the paleosol looks. It's real soft, real easy to kind of pick at with your hammer. And so this is moving us more into the that kind of unconformity boundary now. And so now we're going to start looking at this this tablature, this last layer of limestone we got here. And we'll see some more kind of marine fossils in place here, some crinoids. Let's see, we have, here's just another shot of those. And here's another shell in place in the limestone there. And here's just, so now we're going to start moving, so as you're facing the cliff, we'll start moving to our left. Up a little ways, and so this is our viewpoint now, looking down towards across the other side of the cliff. And so now what we're looking at is we have this unconformity boundary, and what that's going to look like, so we have this kind of dark gray here, which is a very thin layer of conglomerate, which is separating the limestone from the Dakota sandstone, which the Dakota sandstone is going to mark kind of that boundary. The Dakota sandstone is Cretaceous in age, whereas the limestone is Permian in age. And here's just a couple more shots of that. And so looking up close now, we can actually see we have some bryozoans, some of that lacy looking fossils as in the sandstone, as well as some crinoids on the right side there. And then as we move up, we see that the sandstone is really hard to see in place, but we have some pieces that have like fallen off and been displaced. So this is where you can see that yellowish brown sandstone that's described in the stratigraphic column that we looked at a little earlier. And so then moving your way up even further, then we just top it all off with some loess, and this is just some quaternary alluvium, basically just deposited all the way across the top. And so that's your tour of the outcrop at Schramm State Park in Nebraska, and I hope you enjoyed the tour.